Hi, welcome back for the last video on how to do this truss. Thanks for hanging with me here, but right now we're at point D, so let's take a quick look at this. And we're going to do this fairly rapidly. They become easier with the more knowns that you have. So let's look at point D. And let's ask ourselves, do we really need to do anything at point D? So I'm going to draw point D. Got here is my point D. I have a force coming in at 1,500 pounds, up. That is right here. I've got 707 coming down at a 45-degree angle. Compression, meaning it's pushing that. And this is my force AD. I have a force coming down 500 pounds in compression. That's my force BD. And I have a force coming in here at 707 pounds in compression. And I have a force coming in here that we already said was 0. So when I look at this, just as a validation of everything that I've learned so far, I'm going to say that my summation of my forces in the x direction has to equal to 0, and the summation of the forces in the y direction have to equal to 0. And what I'm going to do is look back at my past work and show that I have got a vector here that makes up my 707 pound. And that's 500, 500. A vector here that makes up my 707 pound of 500 and 500. And I can go through and cancel these out. So I've got 500, 500, 500, 1,500 in my y direction. So the summation of the forces in the y direction equals to a minus 500 plus a minus 500 plus a minus 500 plus 1,500. Does that equal to 0? The answer is yes. Now I can do the same thing for the forces at x, and I can say I've got a plus 500. Let me use a different color here because it'll be a little better for us all, a little less confusing here. So I'm going to go ahead and highlight these in green. So my summation of my forces in x direction has to equal to 0, and that equals to a plus 500. I've got nothing here, a 0, and a minus 500. It's going left. Is that true? Yes, it is true. So I've arrived at the general conclusion here that all of my numbers are valid. So at every node that I look at within my frame, and this is the big picture, whether I'm looking at point C, point E, point D, B, or A, they all meet this criteria that the sum of the forces in the x and the y components equal to 0. That is because it was a determinate truss. So that completes all of your truss work. What I'll do is go ahead and clean up this presentation, and I'll show you what you ought to be able to see here. So you ought to be able to see all of your forces that are existing. Unfortunately, I wrote on that. You'll see all of your forces that exist within your diagram. So 1,500 pounds there. And that vector is actually up 1,500 pounds. So that's essentially what your truss diagram ought to look like. So you've got a force and a compression or tension comment for each one of the forces within the members. So that's the solution, the end solution of the truss. Thanks for watching. Hope it helped.